we can get way, way, way beyond a currency and way beyond just kind of a stored value mechanism as a replacement for gold. But to do that, we first of all need to understand what are decentralized apps. Yeah, so decentralized apps, sometimes they're called smart contracts, but I like the term decentralized apps or dApps more. I think it captures more correctly what they are. When we call them smart contracts, it tends to actually conflate a contract with a legal term contract, and they're actually quite different. So a decentralized app is not a contract in the legal sense, but more in the computer science sense. So we'll just use the word dApp. And the primary example for this is the Ethereum blockchain, which kind of introduced the idea of a dApp. And so let's see how it works. So the idea behind a decentralized app is essentially a program that runs on the blockchain. Yeah, so the people running the program are actually the miners who write data to the blockchain. And so abstractly, the way a decentralized app works is as follows. So here we have the Ethereum blockchain. What happens is somebody wants to create a new decentralized app, a new dApp. So the creator, the owner, basically issues a transaction to the blockchain that initializes the dApp. In particular, it creates and writes the dApp program onto the blockchain. Okay, so a miner in the Ethereum network, for example, adds this transaction to a block, posts it to the blockchain, and boom, the dApp is created on the blockchain. So the code is written on the blockchain. Everybody knows what this code does. This is kind of open source in that the application is completely runs in the public. It's initialized to a particular initial state. And let's say that initially the value associated with the dApp is 0. Yeah, so every address in Ethereum has value associated with it. Let's say that initially there is no value associated with this, with the address corresponding to this dApp. Okay, then somebody comes along and says, I want to send 1 Ether to the address of this dApp. Why you want to do that, we'll see in just a minute, but suppose the user decides, I want to send 1 Ether to this dApp. Well, so again, they issue a transaction, a miner validates the transaction, adds the transaction to a block, and posts it to the Ethereum blockchain. And then what happens is basically the code of the dApp never changes. This is fixed forever, but the state of the dApp now has changed. And in particular, we record that the value of the dApp address is now worth 1 Ether. Okay, so what just happened here is that the user sort of sent a request to the program, the dApp. As a result of this request, there was code being executed in the dApp. That code moved the dApp to a new state and added value to the dApp address. Okay, so people often ask, well, where is this code running exactly? And the answer is the code was run by the miner who actually created the block that contains this transaction. Okay, so the miner ran the code, wrote the transaction that contains now the new state of the dApp, and wrote that transaction to the blockchain. Okay, more precisely, the miner actually verifies that the state was computed correctly. And in fact, not just that miner verifies it, presumably all the miners in the network verify that the state is what it's supposed to be. So state 1 of the dApp is in fact what it is supposed to be after receiving this message from the user. Okay, very good. So now the dApp transitioned to a new state. And again, you realize the code in the dApp is the one that governed the evolution of the state of the dApp. The next thing that happens, let's say some other user issues another transaction to the dApp address. So what happens now is, again, the same thing. The code runs. And again, who runs it? Well, the miners basically verify that the transaction was constructed correctly according to the code in the dApp. And let's say that what happens now is the code in the dApp decides to send 1 Ether to some other address. Okay, so this user sent a particular message to the dApp, and as a result of that message, the code in the dApp says, send 1 Ether to an address that the dApp code specifies. Okay, so after that happens, basically, the code never changes. The state of the dApp evolves to the next step, and now because the dApp sent its value somewhere, the value of the dApp now drops to 0. Okay, so that's kind of how these decentralized apps work. Okay, so there's a code being created, then essentially the dApp runs on the blockchain. And when I say that, I mean the miners are the ones who are actually running the code and verifying that the state is evolving correctly according to the code. And the amazing thing is this code is able to send money back and forth it's able to receive money to its own account, to its own address, and it's able to send money from its address to another address. So let's look at a kind of a bit of a contrived example of a dApp. This is a bit silly, but we'll see real examples in just a minute. This is just an easy way to explain the idea. So imagine we have like, I want to buy, as a user, I want to buy rain insurance on a particular day. Okay, so basically once the dApp is established, so maybe some insurance agency sets up this dApp, and now this dApp is going to accept requests. Okay, so the first request is the user who wants to buy an insurance policy. What he will do is he will send the insurance premium to the dApp address. So the premium, say, is 1 Ether. And say the user here wants to buy insurance against rain on June 1st, and he wants the policy to be worth 10 Ethers. So if there's no rain, he doesn't get paid. If it does rain on June 1st, he gets paid 10 Ethers. Okay, and the 1 ETH here is just the insurance premium, how much he's going to pay for this insurance. The next thing that happens is an insurer sends a message to the dApp saying, yes, I'm willing to accept this policy. Here's the 10 Ethers that I guarantee this policy with, and I'm telling you that I accepted the policy that the user suggested. Okay, then June 1st comes along, and now we have to decide, did it rain or did it not rain? Well, for that we use what's called an oracle. So in this case, we'll use the weather service as an oracle. So the dApp, basically, when it was established, it basically says, I will accept the weather messages from the address of the weather service to be authentic, to tell me whether there was rain or not on a particular day. Okay, so the weather service basically sends a message. The message has no value, but the message says on June 1st, in fact, there was no rain. Okay, so now the dApp received a message from the oracle, the weather service. It knows it's authentic because the message is signed using the weather service secret key. And then the code in the dApp said, well, fine, if on June 1st there was no rain, what I need to do is I'm going to send, say, 0.1 Ether to the weather service to compensate them for their service. And then I'm going to send the insurance premium, plus I'm going to refund the policy cost to the insurer. Yeah, so I'm going to send 10.9 Ethers to the insurer. If it did rain on June 1st, what the dApp would do is it would send the 0.9 Ether to the insurer and then 10 Ethers to the user who bought the policy. Okay, so that's a very simple example of a dApp, just to show you why people might want to send money to the dApp and why the dApp might need to distribute those funds as it operates. Now, I want you to understand that these dApps basically are capturing what we would call business logic, right? Very simple business logic is captured here. And in fact, all dApp programs basically in one way or another capture some form of business logic that says, if I receive these amounts and these events happen, I'm going to send those amounts elsewhere and so on. Yeah, so that's basically how dApps work. And now let's look at a couple of examples of what dApps do. So the first example I want to mention is actually a game. But before I do that, it's a game called Cryptokitties. But before I do that, I want to emphasize one more time that the code for the dApp is completely public. It's written in the clear on the blockchain. In the case of Cryptokitties, you can even see the source. You can see the source code is available. Anyone can go to this address. Yeah, you can just write down this address if you wanted to. And basically look at the code and see exactly how the Cryptokitties games operates. We'll talk about Cryptokitties in just a minute. Not only can you see the code for the dApp, you can even see all the transactions that were issued on a dApp, and you can see exactly how much money the dApp has at any given moment, exactly how many transactions were issued on the dApp at any given moment. So everything is in the clear, everything is public, and everything is publicly verifiable. That's how these things operate.